Welcome back to my video. Now we will talk about the NAT, concept of dynamic NAT versus static NAT. What is this? What is the dynamic NAT? The NAT dynamic is many to one with translation many private IPs to one public IP, and the NAT static 1 to 1 which translates one private IP into one public IP. The static NAT, network address translation. NAT is the network address translation, or NAT is the process by which one or more IP addresses local is translated to global IP or vice versa. NAT generally operates on device, router, or network firewall itself. NAT is used to translate one IP to another. For example, from private IP to public IP. The static NAT is a one-to-one mapping so private IP is translated into one IP public. The NAT, if there is a local server that you want to access from the internet public network, example, only access from the LAN because the IP is private. But of course, when you go home, if we want us to still be able to access the office email, then we make a static NAT by allocating a public IP for that email server, for example, to 323.2. So if there are other server that you also want to be able to access from the internet, then add the NAT line static again. So that is static NAT. Static NAT is 1 to 1 with translation one private IP into one public IP. Okay, then now dynamic NAT overload translated multiple private IPs with just one or some public IP only. NAT overload is useful if there are many users with private IPs want access to the internet. Another term for this type of NAT is PAT, port address translation. Then fourth, in addition to dynamic NAT with overload, there is actually only dynamic NAT. However, dynamic NAT requires the same number of private IP and public IP, so it is not effective to use. Okay. The goal, there is goal. We have a topology and goal for this lab. In this topology, we want to be able access the server from the computer here. So here we have a private network, and here the public network. So we want to be able to access the server from the computer. So first of all, you should to put on the router and put in IP address and routing protocol BGP, and you should to put the default route protocol from the customer. The customer is here, the computer is customer. So yes, you move to the desktop and you put a IP for this computer. The default gateway is okay. We move to the second computer. Okay, then we put on the router. We create creating a sub interface for the computer 1 and 2. So the computer 1 IP is configuring IP routing on a LAN sub-interface is only allowed if that sub-interface is already configured as part of AAA. Okay, we configure the encapsulation on queue. Then we put the IP address. Okay, we move to the interface, sub interface 1.20 resolution .1q20 and IP okay, we move to the switch and we creating a VLAN 10. Okay, we exit, then VLAN 20, we exit, we move to the interface FA0/2 and transport model access transport access VLAN 10. Okay, then we get back to the router, and in this router we put on the interface 0/0 put the IP address 2020.2. Then we move to the router 2 CLI. No shutdown IP. Oh, I wrong for the IP address. I erase first, then I configure again. The correct one is right. When we move to the router 1, no shutdown. Okay, then last is desktop IP, and the IP is 172.60.10.2. The default gateway is 60.10.1. Okay, and next step we put the configuration, OSPF configuration. BGP protocol, routing protocol. Okay, we move the router 1. This is the router 1. This is the router 2, and this is the customer. Okay, the router 1 we exit, then root BGP 1, and we put on the network. We put in the network from this router is 10.10.10.2 from the router 2 network remote ES is 2, and the network from this router is 172.60.10.0. The mask is and the second network is 10.10.10.0. The max is 155.0. And we move to the router 2. The router 2 we exit router BGP 2. The network is 10.10.10.2, no, 0.1. The AS is 1 up, then network is 10.10.10.0. the max is 255.0. The second network is 10.20.20.20.0. the max is 155.0. Okay, We move to the next step is default router for the customer. Okay, we move to the router customer. Here we exit, then we route IP route. The default route is like this, and the default gateway is interface router 2 connected with the router customer is 10.2020.1. Okay, now we will try to get ping the web server to ping. Okay, one more success. This the 100% 5445 is successful. Okay, we move to the next step. It can be seen that the customer's router has successfully pinged the Google server because the router's source address is a public IP. Meanwhile, if you try it from the customer's PC, you can because the source address of the customer PC is IP private 192.168.10.2 and 20.2. So here we need to embed the NAT configuration on the customer router. Okay. First we put creating for the access list. Access list 1 permit the customer card and the second customer. Okay, then IP NAT inside source list 1 interface. This interface we overload and we get the interface 0/IP now outside. Then we get the interface sub interface IP NAT inside and the second computer IP NAT inside. So here we go. We try to get ping from the customer computer to the web server. Okay, we try to ping the computer and the router customer. Okay, here we go. I think something happened here. the IP. Okay, we check the switch. Okay, here we go. I think the problem is the switch not trunk to the router, not yet. Then can pass the package is cannot pass because it's the different VLAN. The VLAN can pass is the VLAN 1, is the VLAN 10 and 20. We should to put the configuration VLAN trunk, VLAN allowed trunk configuration. So okay. This what model trunk. Okay, we first for time, then we should to getting back the router. Okay, it's the reply from the router. Then we ping the web server is reply. Okay, then is it successful? Maybe in the next video I will talk about the static NAT configuration. Okay, that's all. Thank you guys for watching this video. Hope you can understand what I say. So see you.